Even from the point of view of the US government, figuring out the nature of unidentified anomalous phenomena should be a priority.
Welcome to the continuing series of the award-winning Mars documentary titled Blue Planet Red. Today, I'm speaking with Professor Avi Loeb. He received his Ph.D. in plasma physics from the Hebrew University of Jerusalem in 1986. He's currently a professor of science at Harvard University, a New York Times best-selling author, and leads the Galileo Project, searching for evidence of extraterrestrial technological artifacts. This interview was conducted on the eve of a pivotal congressional briefing in May 2025, hosted by the House Committee on Oversight and Accountability and the UAP Disclosure Fund.
We've had a lot of people try to dispel the research that the UAP community has done, and so we're just simply putting out the facts and letting the American people, really the world, decide for themselves.
This is the biggest cover-up of our lifetime, and we need to get to the bottom of it.
Professor Loeb was invited to present.
Let us be honest. There are objects in the sky that we don't understand.
One question that I wanted to know the answer to before I die is whether or not we're alone in the universe. We can imagine all we want, but I'm like you. I want to know, and I want some data. I've come to the conclusion that it seems like we're answering that question, or at least in the middle of answering that question right now. Let's talk big picture here, okay? There was a boy raised on a farm in Israel who grew up to become a tenured Harvard professor of astrophysics, who is now proactively searching for signs of extraterrestrial civilizations. And here we are on the eve of a congressional briefing, of which you've been invited to participate by the House Committee on Oversight and Accountability here in Washington, D.C. And we are now living in a world where NASA has even set up a department to study UAP. It seems like we've come a long way from weather balloons and swamp gas.
Yeah, we have the scientific tools to answer this question. And it's only a question of putting the resources and our attention to addressing it. A lot of people have an opinion. But science is all about evidence. And I get a lot of opinions sent to me by email every day by people, and I tell them, look, you should think of me as a kid. I'm just trying to figure out reality without assuming that I know the answer in advance. And it's a learning experience. And it requires a lot of work. It requires going out and observing the universe. And that starts with our backyard, near Earth, but also looking farther away at any objects that entered the orbit of the Earth around the Sun from outside the solar system. And even beyond that, we might look for technological signatures that would inform us that we might not be at the technological center of the universe, just like we are not at the physical center of the universe. And it's very arrogant of us to assume that. And obviously, if we limit our attention to what happens to us here on Earth, we might miss the big point that there is a party going on out there. And the only way for us to learn about it is by collecting data. And I say, whoever expresses opinions behaves like the adult in the room, assuming that our past experience can tell us what we might find, and that's the wrong approach. We know that in order to find a partner, you have to go to dating sites. At the very least, you need to check through the windows of your home and see if there is anyone out there, rather than saying, where is everybody? I mean, that is a very presumptuous question that Enrico Fermi asked, because he assumed that when he is having lunch in Los Alamos in 1950, that they would show up and he could converse with extraterrestrials. But first of all, it's a very short amount of time that he is allocating for this. He is not searching a large volume of space. We know that space is, within the Milky Way galaxy alone is tens of thousands of light years, and that's a huge amount of space. And Our galaxy existed for 10 billion years, and imagining that they would show up exactly when you want them to show up is very presumptuous. And besides, we might not be so interesting. That's the other thing. If you look at what happens in geopolitics, clearly there are signs that we are not very intelligent. And so they might not care about us. We are indistinguishable from nature as far as they are concerned. We haven't developed to a level that requires attention. And we need to put the effort to find them, because perhaps we will grow, we will get a better perspective, we will get better. So I behave like a kid because that's the only standpoint that allows me to learn. Whereas many people throughout history behaved like adults, and that's why we don't know the answer as of now. I should say that it may require a lot of effort, and one way to get the answer before we die is not to die. If we develop through AI-assisted medicine, we enhance the longevity of humans, then that would give us more time to figure it out during our lifetime. And if we live forever, we might actually figure it out.
I go on the online social networks pretty much on a daily basis, which I know is something you avoid.
Right.
But there's quite a number of people who won't hesitate to quote Carl Sagan whenever somebody posts something about UAPs or extraterrestrials. The famous extraordinary claims require extraordinary evidence, to which you respond, extraordinary evidence requires extraordinary funding.
Exactly.
Which is what your point is. We're not going to find it if we're not going to go look for it, and if we don't spend the money to do that.
Exactly. And the other thing is the astronomy community within the US, every 10 years decides about its primary priorities for funding. And for the 2020s, the decadal survey that was endorsed by the National Academy of Sciences selected as the top priority to build the Habitable World Observatory by the 2040s, which is an observatory aiming to look at maybe 24 exoplanets and search for chemical fingerprints of molecules that may be indicative of life, like oxygen, methane, and so on. The problem is that these molecules could also be, in principle, produced by natural processes, and you would never know for sure. But more importantly, we should hedge our bets. If we are willing to invest more than $10 billion in the Habitable World Observatory within the next 2 decades, we should invest a similar amount of money in the search for intelligent civilizations, because those gadgets that we may find, or those technological signatures, may be unambiguous. Even from the point of view of the US government, figuring out the nature of unidentified anomalous phenomena should be a priority. We want to know if these are made by adversarial nations, or maybe 1 in a million came from outside the solar system. My point is, let's put $1 billion, which is a fraction of a percent of the annual budget of the Department of Defense, towards figuring out the nature of unidentified anomalous phenomena, and we will crack it. We will figure it out, at least during this period of time. We will look at millions of objects, and if none of them is extraterrestrial, so be it. And then the government can employ the same instruments to monitor the sky over the US. And so, obviously, we helped government do its job, national security related, but we also, in principle, would have very good statistics on objects that are functional, that are orbiting the Earth right now. And I think from the point of view of national security, it makes a lot of sense to make sure that there is that there are no advanced technologies out there that other nations are employing for espionage. And I would try to argue that from a scientific point of view, that's what I will argue in Congress, that we should hedge our bets and search for technological objects, artifacts that may have been sent here. Humans existed on Earth for a few million years, okay, and life started 4.2 billion years ago on Earth. We know that by dating the last universal common ancestor. Recently, it was found that it existed based on DNA research that it was 4.2 billion years old, just a few 100 million years after the Earth was made. And that shows that as soon as the Earth cooled, there was life, primitive life on it, but intelligent life took more time. Nevertheless, conditions on Earth are probably similar to the conditions on billions of other Earth-like planets, which are situated roughly at the same distance from their host sun-like star. And we know about a lot of solar-type stars, and we know that at least a few percent of them have a planet the size of the Earth, roughly the same separation, based on our statistics so far of nearly 6,000 exoplanets that we looked at. So altogether, the message we get is that our environment, the habitat that we inhabit, is not unusual. Okay, it's not something that is extremely rare, and therefore, imagining something like us under similar circumstances is not an extraordinary claim. It's an ordinary claim. We know that we exist. We know conditions are similar on billions of other planets within the Milky Way galaxy alone. Therefore, it's presumptuous to assume that nothing like us ever existed. And in fact, most stars formed billions of years before the sun. So they had time to develop what the Earth had, much earlier. And the Voyager spacecraft, for example, will reach the opposite side of the Milky Way galaxy disk within a billion years. So there was plenty of time for their space trash to reach our backyard. Even if those are not functional devices, we should be able to find those things. So to me, it sounds like an ordinary claim that requires ordinary evidence. And the only way to find the evidence is to invest funds. Now, we have been searching for 50 years for the nature of dark matter. We know that 85% of the matter in the universe is of a form that is not visible, that we can't see because this matter does not interact with light. And also it does not interact with ordinary matter that we are made of. So we haven't found it, and there were plenty of experiments funded at levels of billions of dollars to search for it. We haven't found it. It's not considered a failure of science, because science, very often what you do is you explore the unknown and you don't find what you might be wishing to find, but that's part of science. And I'm saying let's invest billions of dollars in the search for a partner in our cosmic neighborhood. We can do that with telescopes. We can look for objects near Earth that may have arrived from far away. If we invest a few $1 billion over the next 50 years and don't find anything, so be it, but at least we tried.
I have 3 quotes that I've pulled from your Medium blog posts that I just want you to briefly respond to. These are some of the more notable ones that I've found. Regarding extraordinary claims, you wrote that some of the academic behavior can be explained by the tendency to avoid extraordinary claims.
Right.
Can you elaborate?
I will give you an example. Just a few months ago, I realized that there is a whole class of objects called empty trash bag objects that are identified by amateur astronomers orbiting near Earth and behaving in ways that we cannot easily explain in terms of response to gravity. So the assumption is that they are being pushed by reflecting sunlight, for example, and some of them are doing zigzag motions, very strange motions. Now you might argue that, if an object behaves in ways that are unusual, a zigzag motion that is not following gravity, that's an anomalous object. So we should actually look into those objects. Nobody among the astronomers is looking into explaining, to model these objects. I would call them UAPs because they behave in ways that we don't easily understand. And so we should monitor them and figure them out. Instead, the assumption is these are empty trash bag objects, meaning they're very thin, so they are pushed by reflecting sunlight, and as they tumble, they may go in very strange motions. And they might be the pieces from the breakup of satellites when satellites collide, or when there is space debris that is fragmenting. And so the assumption is that these are human-made objects or fragments of objects that were put in space. And then this category of empty trash bag objects is shoved under the carpet as if we don't need to even discuss it. Now, if you're excluding anomalous objects from your discussion, obviously you would argue that there are no anomalous objects. So I think there is something that is not sincere in the way that many scientists approach anomalies. Either they ignore them, or they say the data is not reliable, so we don't need to worry about them. Or if the data is reliable, they try to give them names that do not require any further attention. So empty trash bag objects, meaning broken pieces of satellites, we don't even need to check if that's the case. Or in the case of an object like Oumuamua, that was the first interstellar object spotted back in 2017 by astronomers, definitely came from outside the solar system, but showed behavior that was not anticipated. It was pushed away from the sun without a cometary evaporation. Nobody would suggest, except for me, that this object may be pushed by reflecting sunlight, even though there is a whole class of objects, empty trash bag objects. No, these are pushed by sunlight because we produce them. However, Oumuamua, which behaves in a way that is anomalous in terms of its motion, is not being pushed by sunlight because that would mean that someone else created it. So then I get pushback for such a suggestion, and that's really, I would argue, it's not a honest approach to evidence. So one of the things I find really surprising, and it's even more extreme than what I described so far, is that not only people dismiss anomalies and claim that there are no anomalies. It's sort of like hiding something under the carpet and saying it doesn't exist. But in addition, if anyone wants to study these anomalies, either we don't want to hear about it, or this is a waste of time, that person is doing something that should not be done. And I'm referring here to the expedition to the Pacific Ocean. There was data from US government satellites indicating an object that came from outside the solar system. And together with my student, Amir Siraj, we called it an interstellar meteor. It collided with Earth. And experts on meteors argued, we don't believe the US government data. So the data should not be believed, and therefore we should dismiss this line of inquiry. I went to the Pacific Ocean to collect materials from this meteor. They said he went to the wrong place because it could be somewhere else. They said it's actually not a meteor because a signal that was detected by a seismometer nearby could have been produced by a truck. And I say, what do you mean? We went to the site of the meteor based on the fireball that carried 1% of the Hiroshima atomic bomb energy. A truck does not produce so much energy. And then reporters would write about it and said, oh, what a ridiculous research project to go to the Pacific Ocean, search for a meteor, claim that maybe you retrieved some materials, whereas it could have been just a truck. Now this appeared in a magazine. And the magazine, the headquarters, the editor is in Australia. And I write to the editor and say, how can you report about this without even asking me how we selected the site of this meteor? And he said, well, there is a time difference. And I said, well, it's not about a time difference. You could have waited another day, and contacted me before publishing this. And it's a question of integrity. If you report about science this way, how can we believe any report about politics? And so my point is, there is something not sincere in the way that some scientists are approaching science. Now, I actually would go further and say that their sentiments against collecting evidence, their sentiments claiming that they don't believe some data because it reflects something new, those those sentiments are anti-science. They don't want me to put the effort and collect the data. They want to dismiss the collection of data. They argue that they don't believe the data. And very often you hear people say, oh, there is anti-science sentiments for people in the general public, in politics. What I find is there are anti-science sentiments among people who define themselves as scientists. They just want to hear about the data that supports their previous notions. If there is an anomaly, they would shove it under the carpet. If someone else wants to examine it, they would dismiss the study, even though it doesn't require any effort on their side. So when we brought materials, someone that doesn't work on meteoritic material, argued, well, maybe it's coal ash. This person had no access to the materials. I wrote a few months later a research note analyzing the sample that we collected, where I show that it's not coal ash. Okay, we looked at 60 elements from the periodic table. And I write to the editor, the editor says, this paper should be submitted to another journal because, it requires more attention. And I said, well, but you just published the other claim that is coal ash, and I'm showing that this is not coal ash. So he said, oh yeah, I forgot about it. That's what he said. This is an editor of a scientific journal. So what I'm trying to say is, very often when scientists are saying, oh, there is nothing to talk about, it's because they don't want the discussion to take place. They don't want to allow anomalies because they base their stature on past knowledge, and new knowledge threatens their ego.
One reason I seek intelligence in interstellar space is because I don't often find it here on Earth.
Something else you wrote here, quote, the current academic structure suppresses the efficiency of the curiosity-driven engine of scientific discovery.
Science is work in progress. That's the first thing to keep in mind. So very often you look for something, you don't find it. That's okay. That's part of the scientific inquiry. It's like a detective story. You look for clues that will tell you something about what really happened or what exists. And without being open-minded, without collecting the information, you can't really tell what the answer would be. So there is a lot of effort put in directions that do not prove productive. And that's risky, obviously. If you're not allowing yourself to take risks and to make mistakes and to find things that you didn't expect, you will never find them. And by blocking those paths of research, you are actually suppressing innovation inside. So just to give you another example, 1952, Otto Struve, a very distinguished astronomer, suggested in a short note that we should check if stars have a Jupiter mass planet close to them, because it would tug them back and forth. And moreover, if a Jupiter-sized planet passes in front of the star, you could actually see a deficit in the amount of light that is observed. For 40 years, nobody was actually searching for such systems. Why? Not because it was not feasible, but because the argument of the mainstream was we shouldn't waste telescope time on doing that, because we know why Jupiter is so far from the Sun. It formed in a region where water ice formed, and we have a model for why Jupiter is there, and there is no way that you can find a Jupiter close to a Sun-like star, And then in 1995, so that was more than 40 years, 43 years after Otto Struve suggested it, two observers found a hot Jupiter close to a Sun-like star, Mayor and Coulomb, and they were rewarded the Nobel Prize for that. I went to their paper, the discovery paper. I didn't see a citation to Otto Struve's paper. What does that mean? Well, because so many decades passed by and people dismissed the idea, the idea was forgotten, and they found it by chance. However, if someone would have paid attention, if the community was more open-minded to allowing telescope time to search for such hot Jupiters, which by now there are many examples of, then we could have saved time. We could have saved decades of research, and we could have started the field of exoplanets much earlier. So what I'm trying to say, the efficiency of science depends on the tolerance of the mainstream to consider possibilities that go beyond, outside the box, and the ability of such projects to get funded. If all funding agencies are using mainstream scientists on their fund allocation committees that are basically reproducing ideas that are already popular within their communities, so they are basically using the algorithm of friends of friends. They have friends within their echo chambers that they support, and those friends make sure that they get supported for their projects. You end up with a situation where you just get more data on what is already known, or study what is already known, and you don't break into new frontiers of knowledge, which is the current system. I think it needs to change in order for us to make much more progress much more quickly. And there is no better question to break the mold than the question, are we alone? Is there, and frankly, I find microbes much more boring than an intelligent civilization out there, for a simple reason. If they are more intelligent than we are, if they are more advanced than we are, we can learn from them. There is not much we can, other than academic insights, there is not much we can learn from microbes. I would like to find someone better than me. When you go on a date, when I went on a date with my wife, I really wanted to find someone that is even better than me. And so I compromise and invest more than $10 billion searching for something that is far down the food chain, and why not, search for something like Moses found in the Old Testament. He went out and saw the burning bush that was never consumed, and that gave Moses a sense of a superhuman entity, God. However, if we were to bring a cell phone to Moses instead of a burning bush, he would have been much more impressed. And it would have served a very practical purpose, because Moses spent 40 years going in the desert before he reached the promised land. And if he had the GPS system on a cell phone, he could have gotten to the promised land within a couple of weeks. What I'm trying to say is, he would have been so impressed by the GPS system to think that it's superhuman intelligence that created it, where in reality we know it's humans that created it, with the benefit of science and technology of a few thousand years, and actually it's mostly over the past 100 years. And so my point is, we might be feeling a sense of awe. It would be similar to religious awe when we encounter something better than us, something that was able to produce technologies of our future. And if we witness that, it could bring us first of all, it would inspire us to do better, to learn from them. But moreover, it will give us a sense of humility, modesty, that we really desperately need, since Friedrich Nietzsche said God is dead, and religion lost its grab on society, over the past 100 years of science and technology. Religion is not as prominent as it used to be. However, if we do meet another civilization or encounter the products of such a civilization, it would give us a sense of awe that puts us in place, so in context. We are not the pinnacle of creation. There is something better than us out there. And for me, it will unify science and religion in some way, because we would then admire something that goes way into our future.
Let's quickly talk about verified interstellar visitors. You wrote a book on Oumuamua, so if anybody out there is interested in that, it's got a whole book on it. It's fantastic. Extraterrestrial. And then lately, you've been focusing a lot of your work on, well, I guess both of them, but you've been continuing your work with Oumuamua, but also IM1.
Right. I mentioned IM1 in my second book, Interstellar. And now I'm writing actually a new book, hopefully to be published within a year or so, on the expedition to the Pacific Ocean to retrieve materials from this interstellar meteor.
So for those who don't know, based on government data, you localized its impact on Earth and went out to the ocean to recover microspherules from the seafloor, roughly 2 kilometers deep. How did you even know something like that was possible?
There were previous expeditions that used magnetic sleds, meaning a sled covered with magnets.
Did you know this? Did you have to go find somebody who...
Well, I knew of previous expeditions that were using this method.
Okay.
But we had to develop our own sled because the conditions in the place that we went to were different. I should say this is a rather primitive approach where you put blindly a sled on the ocean floor, 2 kilometers deep, and you drag it with a cable that is 5 kilometers long, attached to a winch on the deck of the ship. And then the ship carries the sled and back and forth across a region that is about 10 kilometers large. And we went back and forth 26 times, like mowing the lawn.
Yeah.
And
you found these tiny little metallic beads,
right,
spherules, which is incredible. But here you got data saying something collided with Earth. You go out to the middle of the ocean, you go down to the bottom of the sea, you pull up these little tiny things, and you analyzed their composition.
Right.
And what came back was not coal ash, it was something anomalous.
Right. So 10% of these molten droplets that we collected had a chemical composition that is different from what you find on the surface of Earth, the Moon, Mars, asteroids, never reported before in the scientific literature. It had elemental abundances that are anomalous. Elements like beryllium, lanthanum, uranium were up to 1,000 times more abundant than in standard solar composition.
That's awfully strange.
It is strange, and it's suggestive of material that came from outside the solar system. But my point is, you can't really tell from chemical composition what the nature of the object was, especially because those molten fragments lost volatile elements that in the explosion. There were some elements from the periodic table that evaporated, and when these molten droplets were made, they were lost, and we don't know how much of those elements were in the original object. And so what we want to find are bigger pieces.
You want to go back.
I want to go back
out to the middle of the sea.
Yes.
Go down again with the sled.
No.
No?
So now put a robot on the bottom of the ocean, a remotely operated vehicle with a video feed that can pick up bigger pieces.
Oh, okay.
So we will see them in real time, and hopefully we will find the core of the object in the wreckage.
Well, I have a quote here on this. If we're lucky to recover the core of IM1, we will easily find whether IM1 was a rock or an interstellar gadget with buttons on it.
Right.
What happens if we pull something up that's got buttons on it? Then what?
Then the question is, should we press a button? And it's not clear, but it really depends on what this object was about.
And I told my students before I left, if we find a gadget and it has buttons on it, should I press a button? The opinions were split. Half of the class said, please don't do that.
But my point is, this project will cost $6.5 million for us to go to. We have already the vessel, a ship that we found, and that has a robot, a remotely operated vehicle, exactly of the type that we need. The team is ready. We know exactly what we need to do. We've been there. We just need the funding, the money, $6.5 million. As soon as we get that, we are ready to go.
Okay.
And I should mention that whoever funds it will be most welcome to be with us on the ship, or we will provide a video feed straight from the ship to wherever that person is.
Man, that sounds exciting. Somebody is going to take you up on that, I bet you. You've got skeptics some might say some haters out there. To me, that's an indication that you're on the right track.
Yeah, frankly, I don't care. I'm not trying to maximize the number of likes I have. I'm just trying to do what makes sense. And, unfortunately, common sense is not common in academia. That's part of the... Now, some of this is driven by the strongest force in academia, which is not electromagnetism, is not gravity, it's jealousy. And just because the public cares so much about it, some colleagues are not happy with the publicity that it gets.
I have another quote here for you. This is a long one, so just bear with me. The shortcoming of the scientific method is in conservative choices of which evidence to seek. Risk-averse committees reduce the chance for breakthroughs. Most often, progress is made in the small steps that do not deviate much from the boundaries of past knowledge. Large steps forward are left to serendipity. They are made despite all odds in a toxic academic culture that is trapped in groupthink. I read that and I went, damn, that's a mic drop moment. Goodness.
Well, that's based on my experience. I'm different than many of my colleagues because I didn't give up on my childhood curiosity. I'm not trying to impress anyone. I'm just trying to figure out the answer to questions that are exciting. And unfortunately, it's not easy. So over the past decade, most of my funding came from donations, from funding agencies that are not federal because they are willing to take more risks.
A buddy of mine in Australia, his name is Jeff Cruikshank, turned me onto this. There's a scientific coalition for UAP studies. Are you familiar with this?
Yes.
They're putting on a conference in a few months.
Yes.
I'm not sure if you're going to it, but there's someone there by the name of Leonard Neuhaus.
Okay.
From a university in Germany. I can get you the details if you want, but he's got a presentation titled UAP Detection on Mars. I was wondering if you had heard of this or not.
No, but obviously we have footage of Mars. There was a reconnaissance mission that took images of the surface of Mars, not in good enough detail. I think it's important to consider doing archaeology on Mars and the Moon for any artifacts that may have landed there over the past few billion years. These are museums that were not destroyed by geological activity. So anything landing on the surface would have been still there, and we should look for these things. And frankly, if I ever go to Mars, I would like to go into those caves, lava tubes underground, and check if there are any wall paintings there.
Let's talk UAPs, otherwise known as unidentified anomalous phenomena, also known as UFOs. Okay. Also known as... It's funny, but it's serious. Back in high school, I wrote a report for my English class on Roswell. I suspected it was probably one of these made-up stories, but I went with it because I felt like I was just compelled to do it. I can't remember what grade I got on, it doesn't really matter, but I remember being a child also, middle school, high school, I guess, thinking and hearing things, maybe on TV or from wherever, and just thinking to myself, one day, if only everybody had a video camera, we might be able to capture something. This was back in the 90s.
Yes.
And here we are today, everyone's got video cameras.
True.
And we've got a Harvard professor who's got gadgets up on the rooftop at Harvard and elsewhere trying to scan the skies to collect some data on anomalous aerial phenomena here. So this gets back to my original point, is that we used to dismiss these types of things, but now we have people in your position. Thank you very much for what you're doing, because you represent, the curiosity of many of us who aren't in your position to do something like this about it. This is very bold work, what you're doing. But now it almost seems like the work that you're doing is delivering on the promise or maybe the hope that a lot of us had growing up, thinking, hey, maybe we can actually get to the bottom of this.
You have to understand, astronomers are looking at the sky, but they are focused on very distant sources of light, far away. So if something flies overhead, they often ignore it. The government looks at the sky for a completely different reason. They monitor the sky to figure out if there are any national security risks, especially at sensitive sites, strategic sites. So the US government is constantly monitoring the sky. You know, they are guarding us in some sense. There were some disappointments, like the Chinese spy balloon. You know, they should have noticed things like it a while ago. But they are also the ones that may see things out there because they're looking for them. Okay, so in order to discover something new, you really need to seek it. And they're seeking such things because they are protecting the nation. Okay, so when the US government starts talking about the subject seriously, and that includes the Director of National Intelligence, it includes the Pentagon, you know, and there were reports submitted to the US Congress about UAP or UFOs, then someone needs to look at it scientifically speaking. Now, the reports are from the past, and my problem with reports, hundreds of reports from the past, is you can't go and verify what they mean because the quality of the data is limited. And so the best way forward is actually to collect new data, because if these objects exist out there, you know, we can find millions of objects by monitoring the sky over a period of 1 year with the approach that I'm currently following with the Galileo Project. So the Galileo Project has one observatory in Massachusetts that is already collecting data. We already looked at 1 million objects in the sky over the past year. We just assembled a new observatory in Pennsylvania, and we will have a third one in Nevada by the end of summer 2025. So altogether 3 observatories. The major step forward for us is to have multiple units looking at the same object from different directions. And we hope to achieve that actually this week, because if you look at an object from different directions, you can figure out the distance. And then you can figure out the speed of the object and the acceleration of the object. So altogether, that allows you to tell how unusual the object is, because as of now, without having distances, we can say that less than a few percent of the objects that we see might be outliers, might be anomalous, less than a few percent. That's not a good number, because I want to find if 1 in a million is anomalous and not human-made. And for that, we will need distances. So the hope is that very soon, within the coming months, we'll have distances and we can tell if there is an object on a crazy trajectory. And I really want to find out. In fact, in Congress, I will be speaking about this approach that we are taking, and I think the government should adapt as well. And I would argue the government should put a lot of money into it, maybe hundreds of millions, just to figure out what is going on. And so, you know, there could be 2 possible scenarios. One in which you monitor the sky, you use the best AI algorithms to figure out what these objects are. That's the way the Galileo Project is operating. So you classify the objects you see to familiar ones, and then you look at the outliers and see if there is anything that behaves in very unusual ways that are not within the envelopes of human-made objects. Okay, so that there is some performance envelope, speed, acceleration, distance traveled away from Earth, and all kinds of. And if based on those metrics, you don't find anything that is not human-made, that everything is within. I'm not talking just about the laws of physics, because there are people who claim, there are some objects violating the laws of physics. I'm saying within the laws of physics, you might see evidence for objects that are beyond the flight characteristics of human-made technologies. Then, if you don't find anything, that's very important, because it now, if we clean that puzzle that we have right now, if we are able to figure out, it's just like in a detective, so you figure out that everything you see is within the realm of human-made technologies, that's very important. And you say, okay, was that a wasted effort? I say no, because now the government can use the same algorithms, the same observatory technologies to monitor the sky. And I'm happy to help them to contribute to that effort. I'm happy that we will be protected against drones or other things that other nations may be using. And it's not just the AI that we have today. It would be AI that we develop in terms of using multiple sensors in the infrared, optical, radio, audio, combine them together, just like our brain is being able to combine information from our ears or our eyes. So this is called multimodal analysis, which is currently at the forefront of artificial intelligence. So being able to develop the necessary software, the necessary instrumentation to figure out what is in our sky by itself is an important development forward. If we do find an extraterrestrial gadget, that would be worth a Nobel Prize, obviously. And I'm happy to have even government officials on the paper that discovers it. What I would like to know is whether government has already some data or materials that are from outside the solar system. If they do, it will save me time. I haven't seen it yet.
On January 2nd, 2025, just this year, an amateur astronomer noticed an object passing near Earth, and it was catalogued as a near-Earth asteroid. 17 hours later, it was realized, oh, this object moves exactly the same way as the Tesla Roadster car that was launched by SpaceX in 2018, Elon Musk. It is a car. It's not an asteroid. They removed it from the catalog. And I actually had a bet with Elon. I am willing to put 1% of my net worth against 1% of his net worth to search, to check if there is any other space entrepreneur who is more accomplished than he is since the Big Bang.
There's a term that gets tossed around a lot these days, disclosure.
Right.
It's a popular term used to designate the actions behind the effort to compel our government to publicly acknowledge that we're not alone, that extraterrestrial intelligence not only exists, but that it is here on Earth, perhaps even having been here the whole time. A friend of mine, Dr. Alison Brown, she tells me that we shouldn't expect disclosure from our government. We should expect to find it within. We should look within for disclosure, meaning, in other words, if enough people recognize what's really happening, we won't need the government to disclose anything. We'll just already know. What's your take?
My take is the sky is not classified, the oceans are not classified. We don't need permission from the government or information from the government to figure out whether there are residents in our cosmic neighborhood. Okay, we can find it ourselves. And relying on government, I think, would be the wrong approach. And that's why I'm working with the Galileo Project to figure it out scientifically speaking. Now, the government could help us, and that would be great, but it's not as if we depend on them.
You know, some people, like the government, frame it as an issue of national security. Others frame this as a spiritual issue. Others, like yourself, scientifically. Who's right?
Oh, I think all aspects will come into play because there is probably a mixed bag out of UAPs. You know, that there are technological objects manufactured by adversarial nations that are out there. So that's of importance to national security. There might be extraterrestrial objects, in which case they will have also spiritual implications for our future. There was a group of devoted Christians that came to visit Harvard, and they wanted to meet with me and discuss extraterrestrials. And they asked me how would it affect their faith if we find evidence for a neighbor. And I said, I have 2 daughters, and when the second one was born, I didn't lose any of my love to the first one. And so assuming that God can attend only to one civilization is very limiting. And I think, it obviously will have a spiritual component to it, any discovery of this nature. But let's first figure it out.
You probably pay attention to the same people I do. Now, whether or not you publicly acknowledge that is a different question, doesn't really matter though, but if even 10% of the reporting regarding UFOs and non-human entities is true, how exactly am I supposed to explain this to my kids?
Well, I don't know which fraction is true, because you just can't believe what humans tell you. You cannot rely on that. That's why FIFA is using cameras when deciding about controversial decisions on the soccer field. They don't ask the players. This is why there are many cases of people that were on death row that were exonerated as a result of DNA tests. And the people that testified against those obviously were very sincere, and they believe that they are telling the truth, but they were wrong because the DNA tests show that that person was not supposed to be on death row. So all I'm saying is we shouldn't believe what people tell us, because they very often are mistaken or have wishful thinking or are illusioned or hallucinating, or some people are really trying to lie. What we should rely on is reproducible data from instruments. So you put instruments out there, they record whatever is out there, you look at it, everyone can check it, and that will be evidence beyond any reasonable doubt. In the same way that the understanding that the Earth is not the center of the universe was beyond any doubt eventually, even though the Vatican tried to suppress the idea early on, put Galileo in house arrest, didn't ban the book of Copernicus until the 19th century, and then in 1992 they admitted that Galileo was right. And that was 2 decades after humans reached the moon. I mean, the Vatican could not continue to argue that the Earth is at the center of the universe, because there was so much data that it was beyond a reasonable doubt. And it's good for them to have admitted that, because imagine those devoted Christians in the Jet Propulsion Lab that would have said, oh, we stick with the Vatican. They would send rockets that would never reach the destination if they thought that Mars orbits the Earth.
Okay, let's ask this question a different way, and then we'll wrap up here. You're trying to collect data on anomalous objects flying in the sky. What or who is piloting those?
So it could be artificial intelligence if they are extraterrestrial. It could be that they have a brain that is not biological necessarily, because the trip could take a very long time that is not suitable for the survival of biological creatures. And it could also be technologies that we cannot even imagine. So what we should do is not assume anything. It's just like having a visitor to your backyard. You should not assume anything about the intent, the way the visitor is operating. I learned that the hard way because my wife noticed one day someone standing on the street and looking at our house. And she said, that looks suspicious. This must be a fan of yours. He has been staring at our house for an hour. Would you mind approaching him? And I went to the person and asked him, why are you looking at our house for an hour? And he said, well, I used to be a kid in this house for 50 years ago. And in fact, in your backyard, we buried a cat named Tiger. And I said, well, I know this name because I saw the tombstone and I thought maybe a tiger is buried underneath. And that taught me a lesson that you should never make any assumptions about a visitor. You should always check what the intent is before you decide how to respond to it.
This is the continuing series of Blue Planet Red, an award-winning documentary film on the history, evidence for life, and catastrophes that contributed to the death of Mars. The documentary includes interviews with NASA's lead astrobiologist, university professors, aerospace industry scientists, and independent researchers. If Mars was like Earth in the distant past, could there still be life there now? What happened to it? And what turned a blue planet red?